In this question, we're told figure 1 shows a sketch of the graph y equals f of x. The graph has a maximum point at 2, 6 and intersects the x-axis at the points -4, 0 and 8, 0. Part A says to sketch the graph of y equals f of x minus 3, indicating the coordinates of the stationary point and the coordinates of the points of intersection of the graph with the x-axis. So looking at our transformation, considering what this means, this is a transformation inside the bracket. That means it's going to be transforming the x value. It's a transformation of -3, which means it's going to be a translation, so it's going to move in the x direction, and the translation is always for inside the bracket an inverse translation, so that means instead of doing -3 places in the x direction, we're going to do +3 places in the x direction. So let's first examine the coordinates. We're going to have our xy coordinates are going to go to x plus 3. Why? Since all the x coordinates are going to add 3 to them. So we have the 3 coordinates -4, 0, 2, 6, and 8, 0. So -4, 0 is going to add 3 to -4, gives us -1. Add 3 to 2 gives us 5. And add 3 to 8 gives us 11. So what we know in this transformation is that the shape of the graph stays the same. So there's the shape of my graph. It's going to cut the x-axis twice. So the first point where it cuts the x-axis, this is going to be -1, 0. Second point is 11, 0. Now the y-axis is therefore going to be quite close to this point, -1, 0. We don't know what this point is, we haven't been asked for it anyway, and then so we just want to mark the maximum as 5, 6. Okay, so that's our transformation done. Let's have a look at part B. Part B says figure 2 shows a sketch of the graph having one of the following equations with an appropriate value of P, Q, or R. So there are 3 different transformations here: f of x plus P, f of qx, or r f of x, where p, q, and r are all constants. So we want to write down the equation of the graph sketched in figure 2 together with the value of the corresponding constant. So figure 1 is our original graph, figure 2 is our transformed graph. If we first look at the x-coordinates, the x-coordinates for the first term doesn't appear to have changed, but for the second term it's halved and become negative, and for the third term it appears to have been divided by 4. So if we focus on this first term here, the fact that this maximum has halved and become negative, if I was to halve 8 and make it negative, I would get -4. If I was half -4 and make it negative, I would get 2. So there's 2 things happening here. There is a reflection in the y-axis. So the reflection in the y-axis means I've got f of -x. So that must mean that the type of transformation I'm looking at here is this middle one, because q could be -1, but also there is a stretch in the x direction, and the scale factor of this is 1/2. Now remember that for an x, the numbers used inside the transformation are an inverse, so instead of it being f of 1/2 x, it is going to in fact be f of 2x. So this means our equation is going to be y equals f of qx, and we're just going to combine these 2 transformations so that we actually get y equals f of -2x. So in other words, q equals -2. Okay, so let's have a look to see how this question's marked. First of all, going back to part A. Part A, if you've got a concave curve, you've got this upside down, if you've got this N shape and a maximum of 6, you get your first standalone mark. If you've got the x coordinates for the maximum as 5, you get a second standalone mark. Then finally, if you get both the points of intersection correct, you get the final third standalone mark. If we look at part B, we are just simply given 2 standalone marks for the correct transformation. You get 1 mark if you've got minus half x, or 1 mark if you've just got f of 2x, but 2 full marks if you've got f of minus 2x. Okay, I hope you was able to understand my solution and that you followed how to mark it.